Welcome guys to another video lesson. Today we are looking at moments from physics, and in particular we're going to be tackling how we can solve explanation questions regarding the topic of moments. So if you look at the specification content, you can see that the moments chapter is a paper 2 content. So you do not need to revise moments for paper 1, and this topic is only for triple science students who are sitting for full PH1. So when we look at the topic of moments, we can see that there are generally two types of questions, the calculation questions and explanation questions. And these are the kind of questions where you have a beam which is supported at both ends, and you place a heavy object on the beam, or really you exert a downward force on the beam, and you have to discuss the forces at the ends of the beam. And this is one of the most difficult question types that you can get at iGCSE level when it comes to moments. So in my experience, these types of explanation questions generally fall into two categories, which I like to call SPF and PAO. So starting with SPF. SPF stands for single pivot focus. And as the name suggests, these are the questions where you have to explain how one force at one end of the beam changes as the position of the heavy object placed on the beam changes along the beam. So an example question could be something like this. Explain how force A changes as the heavy object is moved to the left. So how are we going to tackle such kind of questions? Step 1, guys, is to take the opposite end of the beam as the pivot. And what I mean is, if we have force A at the right end of the beam, the pivot that we are going to use in this case is going to be the left end of the beam. So this is going to be the pivot. Step 2, guys, is to assess how the moment caused by the object changes as a result of the change in distance between that object and the pivot. So in this question, the heavy object is going to be moved to the left. So the distance between that object and the pivot in this case is going to decrease. So we can say something like d prime is less than d. And if we look at the equation for moment, moment is the product of the force and the perpendicular distance between the force and the pivot. So in this case, because the distance between the force or the weight of the heavy object and the pivot, because the distance has decreased, but the force, the weight, has remained constant, the moment caused by the heavy object will also decrease. In this case, the heavy object causes a clockwise moment. So the clockwise moment decreases. Now, if we apply the principle of moments, we know that the sum of clockwise moments must be equal to the sum of anti-clockwise moments. This means that the anti-clockwise moment caused by force A must also decrease so that the opposite moments are equal, so that the beam is in balance. Now, if we look at the moment equation again, if the distance between the force and the pivot is constant, which for force A is indeed true, then in order for the moment to change, the force must change. And because we want the anti-clockwise moment caused by force A to decrease, then it must follow that the force A must also decrease. And that right there is our answer. Force A will decrease as the heavy object is moved to the left. And here is the complete explanation of the scenario in this particular question. You don't need to write everything in when you do the actual exam questions. On the right, I have highlighted the most important things that I think you should include for almost every question of this type. So on the left, you have the complete explanation to ensure that you fully understand how these kind of questions work. Okay, so now let's take a look at the second type of question, which are PAO questions. Now, what does PAO stands for? It stands for pivot at object. And these are the types of questions where you have to compare two different forces at opposite ends of the beam. So these are the questions when two forces are going to be involved rather than a single force, which would be dealt with by the SPF kind of questions. And the major step for these kind of question types is you have to assume that the pivot exists at the object on the beam. So an example question could be something like this. Explain which force, A or B, is larger. So here we are comparing force A and force B, and we have to explain how we reach the comparative conclusion. Just a quick aside, we would also know that the downward force, the sum of the downward forces, is equal to the sum of the upward forces, so that the resultant force is 0. So in this case, W must equal force A plus force B. This is just a quick little side note. So back to the question, step 1, assume that the pivot exists at the object. Now, it's not necessarily the object that we need to look at. It really is about where a downward force is being exerted. So in this case, the downward force comes from the weight of the object. So we place the pivot where the downward force exists, right there. And step 2 is to compare the distances between the forces and the pivot. So here, dB represents the distance between force B and the pivot, and dA represents the distance between force A and the pivot. If we compare the distances, it is obvious that dB is less than dA. And step 3, we are going to apply the principle of moments, and when we do that, we would know that the moment of B must be equal to the moment of A for the system to be in balance. If we convert that into the product of the force and the distance, we would get the following. Now, we know that dB is less than dA, and that means that force B must be larger than force A. So it's something like 10 times 1 equals 5 times 2. Because 1 is less than 2, it must be multiplied by an integer that is much larger than the integer to which 2 is multiplied in order for the products to be equal. So I hope that little arithmetic example helps you visualize how this works. And generally, the force that is closer to the object, which in this case is going to be the pivot, is the force that is larger. So anytime you're dealing with PAO questions, you can deduce generally that when the object or when the downward force is closer to a particular end, the force at that particular end is going to be the larger than the force at the other end of the beam. And here is how I would explain these kind of questions. Again, the key points are on the right, and on the left you have the complete explanation so that you have a full understanding of how the scenario is working. Okay, now let's go ahead and do some exam practice questions, starting with the question from 2021 June paper 2. And here we have a meter ruler, which is going to be our beam. We then have 2 Newton meters, which are going to be our supports. And we have a mass hanger. And basically what we're doing is we're moving the mass hanger from the left to the right. And our job is to explain why the reading on Newton meter A decreases as the mass hanger is moved towards Newton meter B. So in this question, the answer has already been given. The answer is that the reading on Newton meter A decreases. Our job is to explain why that happens using ideas about moments. So step 1, guys, we are going to take the opposite end of the beam as the pivot. So in this case, the right end is going to be our pivot. Now, the mass hanger is going to be moved to the right. So if we look at the distance between the mass hanger and the pivot, when it moves to the right, the distance is going to decrease. If the distance decreases, that means that the moment caused by the mass hanger is going to decrease. In this case, it is going to be an anti-clockwise moment. So the anti-clockwise moment caused by the mass hanger decreases. However, for the system to be in balance, sum of clockwise moments must be equal to the sum of anti-clockwise moments. Newton meter A causes a clockwise moment, and so the clockwise moment caused by Newton meter A must also decrease for the opposite moments to be equal. This means that the force exerted by Newton meter A must decrease, and that's because the distance between Newton meter A and the pivot remains constant. So the force is the only thing that can have an influence on the moment, and therefore the reading of Newton meter A must decrease, and that right there is our answer. So here is a model answer. It is quite lengthy. You don't need to write everything. So here's the mark scheme, including showing you the key points that you need to include. So this is a single pivot focus question type. Moving on to another question. This one is from 2023 November paper 2, and here we are looking at a leg which is placed on two supports. And in this question we are given the following. We are given that the center of gravity of the lower leg is 0.25 meters away from support A, while the support B is 0.35 meters away from the center of gravity, and our job is to explain whether force X or force Y is larger, and we have to ignore the weight of the upper leg, so we are not considering this portion of the leg. So if you look at the question, it is very obvious that we are comparing two forces, and these forces are force X and force Y, and therefore this is a PAO question, a pivoted object question, and therefore our job is to place the pivot at the object. Now in this question, there is no object. So we place the pivot at the position where the downward force is exerted. So the pivot in this question is going to be the center of gravity of the lower leg. Now we compare the distances, and we see that force X is going to be closer to the center of gravity than force Y. Now, if we write our little equation, let's call this force X times 0.25 equals force Y times 0.35. Now, if we look at that equation and compare force X and force Y, we can see that force X must be larger because it is being multiplied to a smaller number, and therefore our answer is that force X is larger. And of course, remember, we get this equation because we have applied the principle of moments, and we have taken the center of gravity as the pivot. So here is how I would write the response to this question, and here is the mark scheme showing you the key points that you need to include for your answer. Alright, now is the bonus section, and in this bonus section I want to talk about why we can assume that the object is the pivot, because this is kind of the elephant in the room and it is very weird, right? Usually we put the pivot at ends of the beam. So why can we assume that the object, or really why can we assume that the position where the downward force is exerted is the pivot? And the answer to this lies in mathematics. So if you do some maths, some algebra, you rearrange, you substitute, you would end up with this final equation. FA times D1 equals FB times D2. So FA is force A, D1 is the distance between force A and the position where the downward force is exerted, and this is FB and this is D2. So FA times D1 would represent the moment caused by force A, about this is the point, and FB times D2 would represent the moment caused by force B, about this is the point. And our algebra has given us the equation, and this equation means that the clockwise moment caused by FA is equal to the anti-clockwise moment caused by force B. And because that equation is true, it means that the principle of moments is true, and therefore this point can indeed be considered the pivot. And so the answer to why we can assume that the pivot can be placed where the downward force is exerted on the beam lies in the mathematics. So I hope this clears the confusion, and I hope this kind of satisfies the curiosity for those who want to find out why that works. And secondly, I want to give you an idea of how to think about clockwise and anti-clockwise directions. So clockwise means you are going in the direction of the hand of the clock. Anti-clockwise means you are going against the direction of the clock. So the way that I like to think about directions is I like to imagine the big numbers of the clock in my head. So 12, 3, 6, 9. And I like to imagine the beam or whatever is being rotated as the hand of the clock. And you know, if the beam goes from 3 to 6 or 6 to 9 or 9 to 12, that's clockwise. And if it goes from 12 to 9 or 9 to 6 or 6 to 3 or 3 to 12, then it is going to be anti-clockwise direction. So I think that's the most intuitive and least error-causing way of thinking about clockwise and anti-clockwise directions. So if you are confused about how you can take the directions, I think this little tip might be helpful for you. But anyway, that's all that we have time for today. Thank you all for watching until the end of the video. If you have any questions regarding today's lesson, please leave a comment down below. And good luck with your examinations. The 2025 November series is getting really close. So I hope you guys are finding success in your revision, and I hope you are enjoying learning. As always, thank you for watching, and I'll see you guys in the next one. Peace.